Hello, everyone. Welcome to this week's Bounty episode of the Day Zero podcast. I'm Spectre, with me is Z. Today we have some Azure stuff, some bugs in Apollo configuration management system, and an SSRF cross-protocol redirect bypass, as well as aCropalypse, which you might have seen circulating around on social media. It's been garnering quite a bit of attention on Twitter and such. But yeah, we're going to start off with the SSRF cross-protocol redirect bypass, which is coming... which is coming out of Doinsec, and I'll let Z take that over.
All right, yeah. So this one was kind of an interesting root cause on it. So they're dealing with the anti-SSRF library, SSRF filter. The way that works is effectively SSRF filter acts as the request agent. So that way it kind of works at a lower level. It is the agent itself, so it sees all of the requests going through, and it can operate at that level. So you can use it with a number of different requests or request libraries. So in particular, they use this request library, but the bug does have an impact, although not exploitable with node fetch. And basically, you could use the idea of this is it's kind of a low level library, works directly with the agent, so you could use it with all of these other, or with whatever request library that you actually want to. Core issue ends up being that as an agent, when you have a cross-protocol redirect, by default, like the node request agent, this is going to get a little bit confusing because I'm saying request agent for like the underlying thing, and it's also the request library. Kind of a really generic name that might make this a little bit confusing, but hopefully you can follow along. You've got the agent set, the agent's doing the SSRF filtering. When a cross-protocol redirect happens, it actually deletes the old agent and replaces it with, well, the code itself just sets the agent to none, and then the default handler will fill in a new agent. The reason that happens is simply because the native Node.js agent or request agent can only be used on one protocol. So you can have like your HTTPS agent, you can have your HTTP agent, but you don't have, at least for the native one, the one agent that works with both without issues. So it has to do this deletion. Not really clearly documented, but effectively what ends up happening in the request library code base is that, like I said, it just deletes the agent when this redirect happens. And what that means is if you are using this low-level SSRF filter, it deletes the agent. It no longer has that filter in place, so you're able to, just by redirecting like from HTTPS to HTTP, you're able to get around all the SSRF filtering by deleting it effectively. So kind of a straightforward issue, but definitely an interesting cause. One, I didn't know that about needing kind of the two agents. They do also talk about this. I mentioned the node fetch library. When it goes cross protocol, it just dies or has an error, whatever. It isn't actually vulnerable because of that. Axios, popular library. You have to specify the HTTP and HTTPS agent. If you only specify one of them, then you could potentially have another SSRF bypass. So that's definitely something to kind of keep an eye out for. But yeah, I don't know. The request library doing this makes sense why they did it. Although I also kind of believe if they're offering the kind of the setup where you provide this options object that contains an agent, where you're being able to provide that, changing its value just seems like, kind of a warning sign or a wrong move in general. And in this case, it does kind of create a security vulnerability when that happens. But also kind of interesting that you do need these two agents regardless. Yeah, I mean, on a whole, kind of straightforward. It needs to change the agent, and its default action just isn't a good move there. And honestly, something just kind of keep in mind and test for as you're trying to do this. Because, I mean, I'm sure there are other cases where this sort of issue can come up. In particular, it is also interesting that you have this really low-level anti-SSRF library that's intended to be low-level so it can be used generically and used with all of these other systems. but yet it's also so dependent on the actual library or the actual user for whether or not it's vulnerable to certain types of attacks. I found that interesting. That's something they also called out in the post. Yeah, on a whole, I mean, it's a bypass by redirecting to, well, generally speaking, I imagine this is going to be redirected to HTTP, but in theory, could go the other way too.
Yeah, it seems like it's also one of those unfortunate cases where it's not a vulnerability that can really be fixed. They kind of talk about this a little bit towards the end, but they state that the request library is deprecated and has been for years. They reported the issue, but they never really got any response from the developers. So, it has been fixed or tried to work around by dependees, but the dependency is going to continue to be vulnerable to this problem, and it is used quite a bit. I think they say like there's 18 million projects or downloads that rely on it, but over 18 million downloads per week. That's what I was looking for.
Yeah,
So
50,000 projects, which is quite a bit. I mean, generally speaking, if something's deprecated, you just shouldn't be using anymore and should move away from it. But maybe some of your dependencies themselves are relying on it. And, you've got, especially Node, you've got some of those long chains of dependencies.
yeah, it's highlighting one of the big weaknesses with like the Node package ecosystem. It's just so entangled that you probably don't even know that your project is using this package if it is. So, it could be affecting you and you might not even know it, and that's just the unfortunate reality of that ecosystem. So, yeah, it'd be worth keeping an eye out on, and trying to see if this dependency is used in your project if you're you know using like Node.js and could be using the request library. But because it's been deprecated, it's not really going to be fixed. So it's kind of like an open secret Ode, I guess.
Yeah, I guess in fairness, though, the main vulnerable use case of this is when you're making those requests part of an SSRF. So even if like a random dependency were using it, odds of that being used in a way that actually exposes it to being abused in this way seems quite a bit less likely. If it's one of those random kind of deep dependencies, because it's not just like it's present and you're vulnerable. You do have to be calling into it and getting it there, and usually for the application level, like they're going to know what library they're using. So I guess that is kind of a saving grace, and that it might be used kind of deep and not actually in a way that an attacker could control the URLs.
That's a fair point. Yeah, the deeper it is, the less likely that there's like the source to sync. So yeah, fair enough. All right, so getting into our next post, we have a post by Ermatic on an RCE via CSRF on Kudo, which is a Git repo manager used for deployments in Azure web apps, which, if you're authenticated into Azure Active Directory, would export a source control management control panel, which gets deployed by default and can be used to manage your Azure web app and configure various things.
Yeah,
So
sorry to jump in there really quickly on you. Uh it's deployed by default, and to log in you need to be on the Azure AD with one of the particular roles. The way you just phrased it sounded like it was deployed if you were authorized for it, whereas it's deployed by default, and if you're authorized, you can access.
yeah. So there is some authentication there and isolation between different users' control panels, but there is some vulnerabilities as they get into here. The first of which is pretty simple, and it was kind of their tip-off that there might be more problems, and that was the fact that they noticed that the cookies that were used for the SEM panel had the same site attribute set to none, and that was on all cookies, including the session cookies. And the reason that's relevant is because that same site attribute is used by the browser to determine if the cookies are forwarded, and typically you would have that set to like lax, or it would default to lax, which would prevent some of those cross origin attacks like CSRF. But yes, where it's set to none directly, there's like no prevention against it. So that kind of got them thinking, like, perhaps there's other cross origin type issues. And that's where they get into the second vulnerability, which was some vulnerable checking of the origin header. So yeah, they did some checking on the origin header. If you passed just an arbitrary one, like they tried to pass test.com, it would give a 401 unauthorized. Um, But they started speculating that, maybe there was regular expressions being used for doing that checking of the origin value. And it seems likely, given that when they tried putting a $sign in after the whitelisted domain. So I guess that's another thing. They do allow, so the origin they're expecting is like your web app subdomain at scm.azurewebsites.net. But what they found was if they included that and then put a $sign after that, to indicate like the end of the string or whatever, in regex, it would actually allow the origin to be passed in. So yeah, it seemed likely that their speculation that it was regex based was somewhat founded. It wouldn't accept underscores or hyphens though, which made it a little bit tricky to abuse because most modern browsers would only accept A to Z underscores and dashes. So the $sign would get dropped. They couldn't really use that trick. What they did end up getting to work though was passing a dot underscore dot, which is kind of where the emoji part of the EmojiDeploy name comes from. And what would happen there is the underscore would be interpreted as the subdomain. And so they were able to get an attacker's site slipped through past the validation again, and an attacker can just set up a wildcard DNS to forward those requests to whatever they're trying to do. I'm not totally sure why this works, to be honest. Because they say that like dashes and underscores don't get them through. Like they have these other examples higher up where they get the 401 unauthorized, and they get that on the underscore dot, but not on the dot underscore dot. I don't know. I can't really speculate on why exactly that happens. There must be some weird quirk with the regex or whatever. But yeah, it's black box. They don't really know 100% either. So you're only left to like speculate.
Yeah,
I don't know if you have any thoughts, C, but
that was the thing that stood out to me with this post is so what they found, like on a whole, was that they could bypass this by using any special character. And the application, so like, they use the $sign, but any special character could have been used in there, except for the dash and underscore, which were forbidden by default at like some other layer. Oh, I'm just trying to find where they mention that. Yeah, so the SCM server request or accepts any request containing these special characters instead of the $sign, um, except for the underscore and dash that are flagged and forbidden. So it's just those two somewhere get flagged and forbidden, and then in this case, if the entire subdomain is the underscore or the dash, then it will let it through. So it seems like there may be two layers of things going on here. One layer that's just looking for like these bad characters in the middle of the subdomain, and another that is maybe doing this actual check and breaks when you have the special character. I can't be confident in that, but my speculation would be that there's maybe two layers of things going on here. And so by having the entire subdomain be the special character, that for some reason lets through, but I'm not sure why that would be the case, unless like the regex were specifically looking for like, starts with a normal letter, because by default domains, like if you're registering a domain, you couldn't register like underscore.com. It has to start with the character, and then actually I don't think you can even register underscore as a domain at all. You can do dashes, but I don't think most top level domains, it is probably specified by the whoever runs like comnet.org, whatever, as for whether or not underscore is allowed, or it might be in the spec, I'm not sure. But I was looking into this. You can't register the underscore domain or anything with an underscore in it. So that's where you do need to do like the DNS wildcard that just responds to everything with the attacker's address. But yeah, so I could imagine like the regex maybe not matching anymore because the subdomain didn't start with a character. And they just found it in this sort of test case where they have like just that one special character. But yeah, it's a weird case, and that is what stood out to me here is just this isn't like your usual sort of straightforward bypass. Something's going on here that isn't exactly clear. My guess is there's kind of two layers going on. One layer's getting bypassed, the other breaks with the regex. But yeah,
so you're
I'm not
thinking like a desync, yeah,
not
some kind of
necessarily a
desync issue on the
desync.
back end. Well, I mean
No,
between the layers where, one it slips through one layer, but
and then
yeah,
breaks the other, but
breaks
not
the other. Yeah.
necessarily them both parsing it and parsing it differently as I'd usually take with a desync. It could just be the two layers are doing different things. So yeah, I wouldn't categorize it in my mind as a desync, but I kind of see where you're getting at with that.
Yeah. Um, so, anyways, the main point there is that it ended up working. The way they take this to RCE is they hit the API zip deploy endpoint, which is used for uploading and deploying code via zip file, which it'll unzip those contents into the web root. This was also a little bit tricky to get working, as it's expected that you send like a X web form URL encoded request with a UTF-8 character MIME type. If you just send a typical request without the encoding, it'll give you like a 403 a forbidden response. But again, kind of a funny thing where the server just accepts a text plain MIME type. These requests also typically have some custom headers sent with them, like security fetch and anti-cserf headers, but they're just never even checked. So yeah, there's kind of like multiple weird things going on with this system that like they have these anti-cserf things and they just don't use them. So yeah, putting it all together, it's possible to set up an attacker server that would use or generate the web shell, encode it into a zip file, and with the CSRF, send the request to the victim SCM server with that zip file and get a web shell that way. So yeah, the RCE aspect was fairly standard, nothing too crazy that you wouldn't expect. But yeah, it's kind of funny seeing the dot underscore dot emoji, being the core of the attack here, even though we're not totally sure why.
Yeah, it's definitely a really interesting case. I will say, I don't see, since you mentioned the custom headers there, I don't see those secfetch headers actually validated all that often. So it's not surprising that they don't here. And like the X requested with, again, that gets sent. I want to say browsers do that by default because I see that a lot. I don't think people are actually intending to add that. I'm pretty sure that's a browser thing. So
Oh,
again,
that would
if
be interesting. Okay.
yeah, so it feels like it's just being sent there and they're just not handling it because they're not really adding that or intending to either. The thing that actually stood to me was the fact that it did accept text plain, which does probably take a little bit of extra work on their side, on the server side, to accept text plain versus anything else. Uh, and that kind of makes them vulnerable to CSRF because text plain is one of those types that you can send as a cross-site or cross-origin request without pre-flighting. So it did stand out to see the fact that it's for that because I mean a lot of websites just don't support text plain. They're going to expect it to come in as that www form, URL encoded or whatever, form data, the multi-part option. And so seeing the text plain here actually stood out to me as rather unique. I mean it's not unheard of by any stretch of the imagination, but it did also stand out as something novel about this particular case that did make him vulnerable. The fact that this thing has like a whole API for like deploying a zip is also just, sensitive and vulnerable functionality, but in the context of the application, it does kind of make sense. It is that source code management, it is managing some of the deployments. It makes sense that it can do this, but a very nice feature to be able to abuse. It also reminded me a little bit of the whole idea of just using or just checking the content type as your CSRF protection. Had they done that here, which is a CSRF protection that I saw every so often when I was working as a consultant, and I always hated it because it was genuinely reasonably effective, despite the fact that it is such like a band-aid and hack over it to just check the application JSON header, but because you can't send that without pre-flighting, uh, it generally was actually effective. So I always hated running up against that.
I can
This
imagine how frustrating it would be. Yeah.
well, especially because in my testing, I wouldn't necessarily look at the content type header. I would just, go into burp repeater or something, test it, see, okay, I can send it, and then realize the header after I think I had, at least a CSRF to report or something. Granted, I mean, that's not like the biggest issue ever to report or something, but I don't know. I remember being frustrated by it a little bit because just as a fix, I hate it because Yeah, I'd rather see people doing like CSRF tokens, which actually even here, I'm a little bit surprised they didn't do anti-CSRF tokens at all. At least it's not mentioned here that the application requires them. So like they're really kind of relying on nothing.
Good faith. Yeah.
Yeah. I mean, like I can't even like especially with the same site. I was going to say they're relying on the same site, but they're not. They're explicitly disabling that.
Yeah, it's strange. There's a lot of strange aspects to it that we can only speculate on. All right,
Yeah,
so
I
with
mean,
that,
I had
yeah,
nothing more to say.
okay. With that said, we'll get into our next post, which is GitHub Security Lab. So GitHub Security Lab put out some vulns in Apollo config management system. 3 vulnerabilities here: a spell evaluation issue, an auth bypass, and a CSRF. Technically, only 2 of them were, accepted as vulnerabilities, but we'll get into that here now. So yeah, starting off with the spell evaluation, they noticed that as you can imagine, the configuration portal lets you configure various settings of the server, including the API read timeout and whatnot. And these values are then updated in Portal DB, which is, it'll then get used, and it'll also get merged with Spring Framework properties, which can be somewhat problematic as if you can pass spell expressions, that's the Spring Framework expression language, you can effectively get RCE through Spring. We've seen spell expression evaluation abused like this before. It featured quite a bit on episode 175, I believe, where we talked about a server-side template injection. But yeah, in this case, the Apollo config dev team didn't really dub this to be a vuln and didn't fix it, as it does require admin level access anyway to do this configuration. But it is a bit of an RCE sync, and it's what they kind of chain the other issues to get to, or what you could chain to, get that RCE aspect. So
Yeah, and on a whole, like I'd kind of disagree. Like I get it when you're thinking, okay, it's admin, it's very privileged already, and they're actually dealing with like some of the code setup. But at the same time, you're going from a website, like a web app access, to server side code execution. Like that is a higher privilege. I don't think anybody can really disagree with the idea that running code on the server is a higher privilege. So
it
to
feels
me,
like
it
it should
feels
be a
like,
security boundary for sure.
yeah, like I get not calling it like, CVSS 10.0 critical, whatever. Like I get not doing that, but like it does feel like a security boundary to me, even if it is privileged off.
Yeah.
But yeah, it does also require kind of knowing or figuring out something that is going to be evaluated this way, because not everything gets evaluated with Spring Expression. It does need to be something that's in one of these value annotations, but that isn't hard to figure out, being that Spring is open source.
Yeah. Getting into the second issue, this one was a little bit more interesting, and it was an auth bypass in the service registry named Eureka, which is used for registering the config and admin service and any number of other services. So the config and admin service they call out particularly because they're so sensitive. And where they are so sensitive, they have token-based auth. But the problem is the Eureka instance runs on the same Tomcat instance as the config and admin services with no auth checks. So if you have access to that Tomcat instance, you can basically leak that token by sending a service registration request to Eureka, ask it to create a new instance of the admin app, and then when you're configuring that admin instance, you specify your own URL, and whatever request is made from the app to the admin service, it'll send the token in the request to the instance URL specified in the payload that you registered with. So I thought this was kind of a unique, like a cool issue that I don't really see too often. I don't know if I'd quite go as far as unique as I was about to say, but yeah, it's kind of neat. Basically, registering your own service and setting up an exfil channel for being able to exfil those tokens. Yeah, I thought it was kind of a cool issue. It's a little bit. They had to do some, finagling to get it to work. For example, they set up like a SOCAT server to be able to leak that token. That way they could sniff the token, but also keep the application functional without breaking it. So, yeah,
Without
kind of
being
a cool
too
issue.
obvious. Yeah, I mean,
Yeah,
it puts you in a fun little, like, man in the middle situation where you're registering saying, hey, yeah, I'm totally the admin application, so go ahead and send me all of your admin requests and I'll deal with them. And then you forward it to the real ones. That's what they're doing with the SOCAT setup. It's just a fun situation to be able to put yourself into. Does take that extra work, but I mean, for an attacker to actually abuse this, you'd probably want to register very quickly, get a request, get the token. unregister your application so you don't need to keep the SOCAT running and then just start using the token for auth against one of the actual systems. Does rely on them being configured to do the token auth. But that isn't necessarily too big of an ask. I'm not actually sure what the default there would be, but doesn't feel too crazy. I'm not sure what the other options are, but yeah, I mean, it definitely just a fun kind of issue to find yourself into, and feels reasonably accessible to me. I mean, hitting the Tomcat core server, I mean, it's meant to be an app server. It's meant to serve things. You'll occasionally have something in front of it preventing you from hitting, kind of like Tomcat. But we've seen a number of issues that have managed to hit the Tomcat server even when it is behind, like reverse proxy trying to block it, doing the whole semicolon dot like directory traversal after that. Has worked to be able to hit other apps, so including the root Tomcat. Sorry, not Tomcat, hitting Eureka. So feels reasonably hittable. Like, there are definitely setups where this won't be reachable from the internet, but yeah, I mean, I think I'll say it again. It's a fun issue. Or a fun exploit.
Yeah. Jumping back on the CSRF chain, the last issue here is a CSRF due to lack of CSRF protection in the auth configuration class, which, while in most cases isn't a huge issue, as they say that most of the methods that mutate data expect JSON encoded data, which, like you were mentioning earlier, has the preflights. There's some methods, such as add manage app master role to user, of the permission controller, that don't take any data and just use path variables to do its job, which could be used in a CSRF context to potentially grant roles to an attacker account. It's worth noting that this wouldn't work on Chrome because, unlike the last topic, they actually do use the lax same site value. They don't set it to none. But in Firefox and Safari and other browsers that don't, default to lax, it would still work. So it could only be taken advantage of on some browsers, but still, there's no CSRF protection on some of those endpoints. And when you're talking about granting, a master role to a user, that can be quite significant, especially if you start talking about chaining with, the first issue, for example, where you could take advantage of like a spell evaluation type scenario. So, yeah, pretty interesting set of issues. As always, pretty good write up from from GitHub Security Lab. Nothing too complicated, fairly straightforward issues, but ones that you would probably have to be in somewhat of a special position to take advantage of. They're not quite like some of the other issues we've seen where it's just like, unauthenticated exported endpoint has very obvious vulnerability. Some of these do require you be in somewhat like a bit of a privileged position, potentially by taking advantage of another bug. But, we've seen plenty of times before that chaining to get that access is never impossible. So, yeah, still very much issues.
In theory, you should be able to change this from improper auth. So assuming you could hit the Eureka application, like from that one, you should be able to hit everything else. You should be able to get into the admin once you leak the token. You're into the admin. You've got admin privs. You can hit the privileged API. Although at that point, you also don't need to do the CSRF to hit the privileged API. But yeah, I think
but you could do some chaining for sure.
Yeah. Well, you'd be able to go for the code execution, that first issue, or abusing the second one first, I believe.
Yeah. All right, so getting into our last topic, we have a bit of a last-minute addition from aCropalypse. So yeah, like I said at the top of the episode, some of you might have seen this circulating around on Twitter. It's an issue that affects Pixel specifically, and has to do with being able to leak like screenshot contents. So you got a bit of a better reading into it than I did, so I'll let him take it away.
Yeah, and this is, actually, let me pull open the tweet here that kind of showcases what the core issue is, in a visual sense. This tweet loads. Effectively, if you're using the default crop handler, like image markup on the Google Pixels phones, and the core bug here may exist elsewhere, but I'll get into that in just a moment. But if you're using that, you like take a picture, you crop it, you mark it up, you do whatever. It may be possible to recover the unedited or larger uncropped, or at least parts of the larger uncropped image. Their example here is maybe you take the image of a credit card, you block out your number, and you crop it. Um, and then an attacker can download that image and then actually recover. And they have this example here for like the whole image of the credit card or the whole screenshot that they use for that. So kind of a cool little information disclosure. It's kind of a last minute add to this episode. I was initially going to put this on our binary episode because in reading the topic, they're talking about the zlib stream, recovering it, a lot of bit level work, but the core issue ultimately comes down to a change in Google's API, where in Android 9 and earlier, when you'd use this parse mode function to write a file, what would happen? And you use mode W, so you can imagine this like opening a file for writing on like a Linux system. You do open file name, then like mode equals W type deal. By default, it would truncate the file, so you would overwrite the file, or actually, I believe the way with truncate works is that it'll clear all of the content or basically make the size equal to 0 for the file, and then you start writing to it, so there's nothing afterwards. But what Android 10 and after does by default is they don't truncate the file. So if you open a file to write to it, let's say you have like 100 bytes in there and you write 50 bytes, when it truncated, those 50 bytes would be all that's in the file. But without that truncation happening, it writes 50 bytes over the first 50 bytes, but then the next 50 bytes, or like the rest of the file, will be unedited or unchanged. And so what's happening here is after that change, when the image that after you've done all your marking up on it, all of your editing and cropping, it writes that back out to the file through this through the parcel file system. And parcel is a whole little complex thing inside of Android that don't really want to dive into, but effectively this is working kind of like an open and write and stuff. But when it writes that back out, it's just using W, so it's not truncating. So if you're cropping a file, and so the file that you're writing is smaller than the original, you're going to potentially have a lot of extra data after the end of the file. All of that contains the original image information, which they're able to recover. And they go into a little bit of actually like finding or like parsing out the Huffman tables so they can actually like do the decompression, like basically recovering the image. They go into a lot of those details, but the core bug here is just that lack of truncation by default, which is different from, like I mentioned, on Linux or on POSIX systems. When you use mode W, it truncates by default. So
it seems like a really weird change to make by Google, I must say,
and to not document.
Yeah. Like I'm not really sure what the motivation would be to be like, yeah, let's make it so that the write mode no longer truncates. Like, I just can't rationalize why you would want to make that change. And yeah, like it seems like something that could cause a lot of issues even outside of this specific case. Like, just for a lot, like thinking it works how it's worked for a long time on Android and other systems. I could see this causing a lot of information disclosures potentially.
Johnny Jim Joe mentions battery life. Maybe I don't think so. Mostly because all it's really doing when it truncates is, I believe, setting the size back to 0. So it's
not like it's using a lot of processing power or anything to do the truncation.
Yeah, it's just size 0 and then kind of remove some things. Setting that, or on the file system, maybe there's a little bit more complex when you're deleting parts of the file, but I think they just no longer get pointed to. It doesn't actually overwrite them exactly. Yeah, I don't think battery life is really being changed here because it's not like it's zeroing the file, or like if you're going for performance on the heap or something where you talk about zeroing memory, it's not like writing out zeros. It's just effectively changing pointers. So it's not really a different, or I wouldn't believe it to be a difference in power. I could imagine somebody thinking it's better to be more explicit or whatever, but
that's what my thought is. I was thinking maybe they want it to be like remove some implicit behavior and be like, if you want it to truncate, then tell it you want it to truncate. But it just seems like one of those situations where there's basically not a lot of benefit to come out of it and a whole lot of bad.
Yeah, and
Like,
root them
even
all.
though it's maybe not explicit, it's probably not something that's good to change.
Yeah, no, like it, especially because it's been such a standard with POSIX that when you open with write, it truncates. Like that is something you can generally expect. It's definitely weird that they made that change. Root them all mentions someone just needed a truncate option, so they changed the API. Maybe I guess I could see that. Like I know that's kind of made as a like uh
Memeing a little bit.
yeah, a bit, but like I could imagine that scenario. Like that does sound like something I could imagine somebody doing. Yeah, it's a weird change to be made regardless. Um probably I'm just going to take a look here. Do they have the actual commit that caused this? Cuz this is I've got the issue up here. Uh yeah, they've got the commit here. I didn't actually take a look at this before the show, so let's pull this up live and see what the commit message is. Utilities for content URIs and file modes. Yeah, with somebody just wanting to add a truncate option, and just added that, and therefore Rife was no longer the default truncate.
Oh, all right then.
So yeah, I mean, it seems like just they're adding in this extra feature and they break everything.
Yeah. So, like I said, I can imagine other information disclosures coming out of this change, other things that rely on that truncation implicitly, even if they don't know it. Yeah, I could totally see that.
For
Now, the
sure.
one
Oh, go ahead.
I was just going to say, the one like sort of saving grace with this issue is it is going to be pretty dependent. Like, you know, context is going to be important for what data you can actually recover with this attack. You're not going to be able to recover, everything. At least in most cases, as I understand it, you're only going to be able to recover pieces of the file. So in a lot of cases, that might not be like something super problematic. But in other cases, especially like their go-to example with taking a picture of a credit card, which you should never really do anyway. But in cases like that, it could be a lot more sensitive. So it's something that's going to be on a case-by-case basis of how serious it is and the impact of it. But yeah, it's a pretty fascinating root cause.
Yeah, I could imagine other places where this could happen, not necessarily where this would have such a big impact. Like the impact here, if it being images, people upload images, they take screenshots and crop them all the time. That's a very common practice. Sure, taking a credit card image maybe isn't the best idea and sharing that, but hey, you're excited you're getting a delivery, so you take a picture of Amazon, it has your address on there, but you just crop the address out or something. Something like that could lead to information disclosure. Like there's a lot of potential there. Basically, though, what you won't be able to recover is the head of the file. So if the head is always very consistent, you may still have some luck or be able to get a lot of the information out of it. They were kind of lucky with this being the PNGs, the compressed things, or zlib compression. Kind of lucky in that setup that they're able to recover a bit of information since it repeats or not repeats, it generates a new Huffman table every however, I think it's like 16 kilobytes they mention. Because it does that, like they're able to recover a lot of the information fairly well, but it is very context specific. But it is a really interesting bug that I think will appear in more locations.
Yeah,
Like
definitely.
it's definitely an issue that
It goes beyond just the image cropping and
yeah,
that functionality. Yeah.
yeah, that's just a very clear, like you have a very clear impact with the image cropping. But
I
I
don't
could imagine this causing some very subtle bugs in other ways. Maybe not necessarily even vulnerabilities, just bugs that are really annoying for a developer to triage and figure out, like, why is my file getting corrupted?
Yeah, because of that reason, I almost wonder if Google will walk that back and revert the write mode to do the implicit truncation. Because, like I said, like even if they wanted to add the utility for doing the flag, like there's still no reason it couldn't do it implicitly. So yeah, I'm curious if that'll be reverted, but it might not be. Like it might be hard to tell unless you're keeping a close look on the Android source trees. So Yurdamal mentioned files with headers at the bottom would corrupt zip, I think. That's an interesting shout as well. Something like zip files, yeah. That could be. Yeah. Now I'm kind of like hoping we see more blog posts of some fun, subtle bugs that are caused by this. But yeah, it could be really frustrating for developers. Could be a frustrating time coming up. But yeah,
Yeah,
that's a good point.
it's a cool bug. Like it's yet another case of kind of high level bug that with all the security protections we can come up with wouldn't catch something like this.
Yeah, yeah, it's pretty subtle, especially where it was never documented, which is the other problem with it. So
Yeah, well,
yeah,
now it's documented.
now it is. All right. So yeah, that's pretty much all the topics we have for today. So Z, unless you have any last minute thoughts, we'll go ahead and wrap it up.
Yeah, no shout outs this week.
All right. So as always, thank you everyone who tuned in. Recent episodes can be found on Twitch, and all of them are up on YouTube, Spotify, Apple Podcasts, and more links on Anchor. Discord and Twitter links are down below or in the chat for those who want to join the Discord or follow us on Twitter. And yeah, we'll be back tomorrow at 7 p.m. Eastern, 4 p.m. Pacific for the binary episode, which is also where we'll cover the Spot the Phone solution. And we'll see you then.